Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to take a look at something that for the moment, just for the moment, doesn't have all that much to do with Spring, but I think is particularly interesting in light of where things are going with Spring and what the opportunities are for this particular technology. Namely, we're going to look at RSocket. Now, RSocket is a sort of a we could spend all day. We really could. We could spend all day just talking about RSocket. But briefly, RSocket is a protocol that was developed at Facebook. It is the result of a use case, of a need at Facebook to be able to describe integration between systems in a platform and language agnostic way. It is a protocol that is, as I say, runtime and platform agnostic. It doesn't matter if you're running it on Java or .NET or whatever. There are multiple ways to consume it. It is a protocol that is modeled after the sort of the use cases of large-scale services, and as such, it follows that it integrates natively the reactive streams concepts at the protocol layer, at the protocol level. It is actually a protocol that supports reactive stream concepts, and the Facebook implementations, of which there are three right now. There's one for C++, one for JavaScript, and one for Java. The Java-based implementation naturally builds upon Reactor, and so Reactor, of course, is the Spring Team's sort of reactive library for integration that implements and supports the reactive stream specification. And the question then, of course, is why RSocket, right? Why this solution to what might seem an already crowded space? Well, when you consider what we're trying to do here, we're trying to integrate different disparate sort of services and systems and so on. Reactive streams, I think we can all agree, it provides a nice foundation for modeling that integration in Java, right? Reactive streams rely upon asynchronous message passing to establish boundaries between components and ensure loose coupling. There are other benefits, right? There's location transparency, there's isolation, etc. And there's also in true functional style, there's a first-class way of expressing errors, as in the same way that you treat and manage data, you manage and treat errors. Because you have message passing, you have asynchronous sort of decoupling between integration boundaries. You can very easily now apply messaging sort of patterns to reactive code, right? You can use things like load balancing. You can scale out horizontally. You can do pub sub. You can do flow control by pushing back on the producer of the messages. So you have a lot of really interesting ideas in the reactive stream specification, and these are things that you want in a sort of application layer protocol. Now, some might look at HTTP2 and say, well, isn't that an application layer protocol? And the answer is no, really, it's not. It's a much better HTTP. HTTP2 is a more efficient HTTP, but ultimately HTTP was designed for document retrieval. The verbs expressed therein map to document retrieval. This is not a application layer protocol. It doesn't really support anything besides request response. There is the concept of push promises, right? This idea that you can send down preemptively information down to the client, but that still requires an explicit request. It's not true bidirectional communication. And if you want to do things like fire and forget, you can't do that, right? It's not as easy because the machinery of the web server is still going to process the response, even if the client then ignores it, right? So you run into problems when you use HTTP for application level concerns. The RSocket website explains some of these, but basically there are some issues. There are some issues that bubble up from trying to use HTTP in this way. One is that when you do HTTP 1.x, you get a head of line blocking, where effectively only one request can be outstanding on a connection at a time. This is not a tenable situation to be in when you have large scale and you need to be able to queue and then process as much work as possible. HTTP 1.1 tried to fix this with pipelining, but of course it didn't completely address the problem. A large or slow response can still block others behind it. Um, and pipelining is hard to implement correctly because you've got lots of middleware in the pipeline, a lot of middleware in between different producers and consumers that don't necessarily know what you're trying to do, so they can end up trying to proxy, for example, incorrectly and so on. So we then see that there's a number of heuristics that people rely upon. Obviously, multiplexing fixes some of this. It allows you to have multiple requests in flight at the same time. Um, but we still don't have everything we need, right? We still don't have everything we need, and ultimately, we need support for things like persistent connections, right? So persistent connections uh, help you reduce the number of open connections at a time, right? Obviously, too many open connections is a bad thing because it means that your network infrastructure is now trying to deal with congestion, and that congestion can punish otherwise well-behaved applications that are running in the same area, in the same space. So you're stealing essentially from other better behaved applications. So these are all problematic issues with HTTP. Um, there's also the other issue of just being it's just very simple. It supports request response basically. If you want to do full bidirectional communication, that you can't do that with HTTP. So you might do it with WebSockets, for example. WebSockets is an interesting option there. You might do something like server send events. Well, WebSockets provides message framing. That's it. It just provides this demarcation of payloads over the wire. It allows you to say this is one whole thing. That's it. It doesn't give you any other application level concerns. It's up to the developer to sort of address that. You might do server send events, which is a simple protocol that is textual and porous and bandwidth demanding, and that does message framing, and it's only for one direction. It's server side to client, but that's a little bit that's kind of interesting. It also requires text, right? You have to encode binary data in some way that can be represented in characters. So we have all these issues, right? There's all these sort of like issues, small issues, none of them particularly huge, but death by a thousand cuts, as it were, and that matters especially at Google and Facebook and Netflix scale, right? But that might also matter to you, particularly because, as I say, beyond the concerns of bandwidth and efficiency, we have just the sort of limited nature of HTTP, right? What if I want to make a request and then just leave it there, just send a request and not get the response? I'm not interested in the response. I'm not interested in the acknowledgement, and so on. That's fire and forget. That's a very common thing to do in a messaging architecture. And there are optimizations you can make on the infrastructure if you know that the request was only ever intended to be accepted but never responded to, right? That's a lost opportunity there. Similarly, what about sending large amounts of data? Again, if you want to send unlimited streams of data, then you're kind of in a pickle here, right? WebSockets is an option here, but again, that has some limitations. And then, what if you want to do server-side push and client-side push? Like you want to have a channel, a bidirectional channel wherein both sides send potentially unlimited streams of data. Again, you might use WebSockets here, but again, you're missing out on application semantics, application level sort of framing semantics and so on. So there's that, and also with HTTP, we're so used to thinking about it as sort of it's either one response or it's multiple responses. Like with WebSockets, it's very easy to, or server send events, it's very easy to say I'm going to send a potentially unlimited stream of data, versus I'm going to use JSON. I'm going to use application JSON to send this one finite array of data with 8 records. Well, there doesn't need to be a distinction there. It could just be I send one record, I send 1,000, and if I send 1,000, then I send it in chunks. And that means that I don't have to wait for the whole response to accumulate. I can just start processing it as soon as possible. This enables some very interesting possibilities, particularly in bandwidth-constrained environments, mobile environments, etc. The other thing that we're missing in HTTP and other protocols is, the foundational sort of application flow control guarantees made by the reactive streams, right? Specification. How do you push back on the producer? How do you apply back pressure? And when you do have back pressure on the, you can slow the rate of consumption. The client, the consumer of the data, can slow the rate of consumption for the producer by requiring or requesting rather less records in the next response. That's one thing to do. But there's the other direction as well, right? The other direction is if I am a producer, I can send information to the client indicating to the consumer, rather, I can send information to the consumer indicating what my availability is, how much capacity I have, what my uptime, any kind of interesting information, whatever that is. I want to be able to communicate that to the consumer to give it an idea of my ability to respond to its requests. So that would enable load balancing patterns. That would enable routing discussions and decisions. Right. This is this communication is something that should be handled at the protocol layer, and yet we so often have to reinvent it, right? So it's much nicer to have this in the protocol itself. So you can see there's a lot of use cases here that are just sort of, there's 1,000 different ways to solve these issues, but I guess at some point Facebook just said, look, we're trying to graft on top of HTTP and WebSockets and all these other things application layer concerns when this wasn't meant for that. So let's instead try and solve it more efficiently in a different way. So RSocket seeks to reduce perceived latency and increase system efficiency by supporting non-blocking duplex async application communication with flow control over multiple transports from multiple different languages. It reduces a hardware footprint by increasing CPU and memory efficiency through the use of binary encoding and avoiding redundant work by allowing persistent connections. Similarly, we avoid handshakes and the associated round trip where possible, right? And we reduce computation time by using binary encoding. We allocate less memory and reduce garbage collection costs that way. So RSocket has a lot of benefits to it. It is ultimately just a layer 5 and 6 or TCP/IP application layer protocol, and I think it makes it a good choice for application developers. It's not the only way. You can still use REST, you can still use HTTP, that's fine. There's a lot of good stuff there, but this is a nice reactive wire protocol, and there's a nice API you can use. Now today we're going to look at RSocket in the context of Spring. Actually, we're going to use it in a Spring application, but there is no Spring integration for it yet. Okay, I say yet because we announced at Spring One Platform 2018 that we would have support for RSocket in Spring Framework 5.2. There'd be a component model a la Spring MVC or the WebSocket support or Spring WebFlux. So you'll have a component model with I expect annotations and a client or a template or something along those lines. And I'm looking forward to that, but it's still useful to kind of take a look at it and understand what's happening. So we're going to use Lombok, and that's it. That's really all we need. I guess we want to use the reactive stuff, so I'll bring that in, and that's it. We're just going to build an app called RSocket, and we're going to hit generate. We're using Spring Boot 2.1, which in turn builds upon Spring Framework 5.1. So not quite there yet, not 5.2. Okay. Now, we're not going to spend all day on this, though we could. Whoa. Don't agree. Thank you. All right. So what we're going to do, we're going to build a few applications that demonstrate some concepts here. We'll start with something very simple. Let's just say I want to make a request and a response, but instead of just getting a single value back, let's call this package RR, request response. Okay. Request response. Okay. And we'll get rid of this. All right, so here we are. We have my request response type, and all I'm going to do is I'm going to build a simple application that will start up. I'll have two things in here. I'm going to have two things that will both start up and listen on different ports. Keep in mind, of course, that those things could run in separate processes. These clients, I'm going to have a producer and a consumer, and they could run and will often run in separate processes. But just to make things clear and to make it simple and to kind of see how these things look next to each other, I find it instructive to develop these kinds of things in tandem in the same code page, and then worry about their separation into separate processes, separate microservices later on. Okay, so public static void main string args spring application dot run request response dot class args. Okay, and Spring Boot application. All right, so there's our Spring Boot, scaffolding, if you will, and from here we're going to develop a producer and a consumer, and our producer is going to be fairly simple. We'll call this a consumer. It'll be a Spring Bean, and we want it to start up. Implements ordered. I'll just give it we're going to use interfaces here because why not? Because we have certain lifecycle issues here, so we want this to start up later, don't we? So ordered, lowest priority. We want this to start up after the server, after the producer, and we'll have a producer here, class producer ordered, and we'll say ordered dot highest precedence. All right, so pretty clear, right? Now we want the producer to respond to incoming requests. So I'm going to listen for an event, and you could use the annotation here at event listener. I often do, but it doesn't really matter in this case, and I've already got a few interfaces. Okay, there we go. So I'm going to listen for that event, and when that event happens, I'm going to start serving data using RSocket. And again, we're going to use the low-level RSocket API. So there's nothing really fancy here. It's just a very simple API that looks like any other network API with which you are probably already familiar. We're going to create a thing that will respond with a stream of data, just an arbitrary reactive stream. And I mean, like, I'm just going to use reactor, right? And by the way, I need to comment this out. I'm going to bring in the Spring Boot starter, but we don't need this. Do we? It's probably safe. Let's just leave that in there just in case. So I'm going to build a producer. The producer is going to listen for incoming requests. So RSocket factory. No, I want to add the RSocket dependencies first, right? So we have to do that. I've gotten ahead of myself, haven't I? So we're going to add the different dependencies here. Usually when you add RSocket, you don't have to worry about it's safe to use these two dependencies that we're going to use, the RSocket socket transport. So let's see here. It is dependency, and it is, please autocomplete for me, RSocket transport netty, and we want to use 0.11.14, I think. 0.11.14. Okay. And I hope that brings in the core. Yes. Oh, for compile time. So we can just bring in. Okay. All right. There's a. Good. All right. So there's RSocket. Here we go. Now RSocket factory dot receive dot socket acceptor. Now the socket acceptor is fairly straight. This is actually where the meat of the work happens. So we're going to move that out here. We're going to say socket acceptor. And our job, when somebody makes a request, is to provide a publisher, a mono, just a wrapper around an RSocket. And so what you're given is the incoming sender RSocket. And here's any setup metadata if you want it. And you can return a brand new RSocket here. And that's what we're going to do. We're going to come back to this in a second. Okay, so to do. And here, it's going to be the socket acceptor. And we're going to use a transport. Now here, I usually use the TCP server transport. But keep in mind, RSocket doesn't care. It's to a point. It's actually protocol agnostic. It's transport agnostic. So remember, I said earlier that WebSockets are appealing for certain use cases, but they don't have application level semantics. Well, you can fix that. There's actually a WebSocket transport. All right, WebSocket transport. Is that server transport? There you go. .create 7002, for example. So you could use this one instead, right? And you can now communicate over WebSocket, over the same protocol and port, and it'll do the message framing, but everything else is done in terms of RSocket. So you can do that if you want. That makes it easier to integrate this into environments that only speak WebSockets. But I'm going to use TCP because it's fast and it works, and we have no reason to use WebSockets in this particular case. Then I'm going to start the code, and I'm going to block on the response on the server. Okay. Now the actual work, as you can see here, is producing this RSocket. So this is easy. You just say I'm going to return a new abstract RSocket. Okay. And we say return mono.just abstract, and this class, there we go. This class has a few methods here. You see RSocket is very flexible. You can see it is transport agnostic. You can see it supports multiple message exchange patterns, fire and forget, request response, request stream, and request channel, and metadata push. We'll come back to all those in a second. And it supports different encodings, or rather, it doesn't specify an encoding of the data in the payload. So when you send data from one producer to one consumer, they must agree a priori on the encoding of that data. You could actually, you could send whatever you want. You could send JSON. You could send Google protocol buffers. You could do whatever you want. There's no requirement here that you do one thing or the other. And everything gets curried back and forth in terms of these payload envelope objects. It's just bytes. These are byte buffers, basically. Now, let's look at this. This fire and forget method says that the consumer, is going to send a request to us, and we're gonna acknowledge the request. So these are callback methods that get called when when a client sends a request to us as the service. Okay. So the fire and forget method expects a payload. A payload is just a single value, just one value. It could be a byte. It could be a string. It could be whatever you want, right? It could be serialized Java object. Don't do that, but it could be. It could be whatever you want. But the point is, that is just one single thing, and your job is just to accept it, process it, do whatever you need to do with it. But you don't get to send a response back. The response is just mono.void, which you can get by calling .then, right? So on most Reactor reactive streams, you can just call .then. So that's one option. Request response is also fairly straightforward. This is more natural. This is I think, if you're in doubt, you might start with this, right? Request response just says, I'm expecting to send a single payload to the server, and I'm expecting a single payload back. So it's one value in, one value out. Request stream is where things start to get more interesting and more stateful, right? You've got now here you've got a publisher that you're sending back to the client. So the client sends you a request with a payload, and then you send back a publisher. And you notice that these are monos and fluxes. These are from Reactor. This is not just Java. This is not just the reactive streams publisher. These are actually specific subtypes from Reactor that are built into this protocol, this project from Facebook. So here, you know, imagine you're doing a find all, or you're doing a, you know, get stock ticker updates or something. So you could say, send me all the stock ticker updates for the stock, you know, whatever. And then the stock ticker symbol is what you send in the payload, and the flux is the updates every second or whatever, every heartbeat event, indicating all the new updates, right? And then finally, you've got sort of complete back and forth, you know, a bidirectional channel. And in this case, you send a stream of values and you get back a stream of values, right? So that's very convenient as well. And then this one isn't a, it's you don't usually use this to communicate data back and forth. This is more about communicating availability. This is more about leasing, you know, telling the requester, you know, pushing back on the requester as opposed to pushing back on the producer. Okay, so let's just try some of these out. Remember, fire and forget is nice if you want to send data and that you want to make sure that the machinery can, on both the producer and the consumer, can dismantle itself as quickly as possible, and you know, to alleviate state. So you can use that one. Request and response is fairly straightforward, so I guess that's, well, I'll just let you sort of explore that one yourself. Let's do request stream. So we're going to make a request and we're going to send back a stream of values. Okay, so we're going to assume somebody is going to request us. Somebody's going to connect to port 7000 on our server, and when they do, they're going to run into this RSocket factory, which is listening there. It's going to invoke the socket acceptor, which is going to then be charged with producing this abstract RSocket, which we send back, right? That's the thing that's going to be put into service to listen to and respond to the sender. And what we send back can be anything we want, right? Let's just imagine you have a service that produces a string of values, okay? A publisher of string, a stream of strings, if you will. So notifications, okay? And so we're just going to do a very common thing. You've seen me do this before, I'm sure. Return stream.of, or generate even. This will be a new supplier, and it'll be a supplier of string. And I'm going to say return hello at instant.now.toString, and that'll be a publisher from a stream. Okay. Good. Okay, look at that. So there's my never-ending stream of data. And, you know, I'm going to delay this. I'm going to actually insert a second-long pause between each published emitted item. And that'll be the publisher that I'm going to send back. So we're going to send a flux of string, and this could be anything. It could be a custom object or a foo or a bar, whatever. You could, you know, as long as you can get it into a payload. So our job is to take the publisher of string and turn it into a publisher of payloads, and that's pretty straightforward, because once you can get this object of yours into bytes or into a string, it's easy from there, right? In this case, maybe we can have the name. What do you think about that? Let's actually have a string name, okay? I'm going to say hello name at this time, okay? Not bad. So we're going to greet the requester with their own name, okay? So here I'm going to say payload dot get UTF-8 data UTF-8. That's the string. You can see that we can get a byte buffer if we wanted to, but I want the UTF-8 data, so I'll get that back. Okay, and we're going to send this back. We're going to say name, and the values that we send back will be return notifications for the name, and we're going to get back a publisher. So we want to take the publisher of greetings and turn it into a publisher of payloads. Okay. Default payload dot create greeting. Okay, there's that. That can be a lambda, their method reference even. There we go, not bad, right? So all we're doing is we're calling default create, and you can see I shouldn't have gone so quick. Default payload crate takes a byte buffer, it takes a byte buffer, it takes a payload, it takes a car sequence. So I'm relying upon the variant that takes the string, the car sequence. Okay, so I'm just saying string. Okay, and that collapses nicely into that, and that's it. That's our server. Okay, and this is I think we can agree this is fairly straightforward. You can even rewrite it as a lambda. That's nice. So there's our producer, and we have this very simple, trivial example. But where can you get a publisher of T from? Well, any of your Spring Data projects that support reactive programming, right? The Spring Data reactive MongoDB, the Spring Data reactive Redis and Couchbase and Cassandra. You can use R2DBC, the reactive SQL data access layer. The nascent Spring Data R2DBC project supports this as well. So we can do all sorts of interesting things. We can source data from a number of different places, and indeed, we could act as the consumer here. You know, we could be consuming data from one microservice, transforming it, and then sending it on to another microservice. We can act as a bridge. It's very natural to do that kind of thing, since we have just publishers going back and forth, right, from hither and thou. So we can do all sorts of interesting things here. That's our producer. Now, the consumer side is similarly easy. So we say it's going to be an application listener, application ready event, and on the consumer side, we're going to say that we want to start up a new RSocket factory. We're going to connect using the TCP client transport, not the server transport, on port 7000. We're going to start the request. I'm going to flat map many. We're going to say once we've connected and we were given it back an RSocket client instance. Once we're doing that, then we're going to subscribe, or better yet, we can block. Or just subscribe, I guess. Okay. Once we're doing that, we'll say RSocket dot, and we're going to request a bit of data. So we're going to send a request with our client RSocket, our sender, right? That's what this is actually. You know, you should think of this as being the sender RSocket instance. When we do that, we're going to send our name. So Spring Tips. All right. So we're going to send that stream, and when we do that, we're going to get a response back, and the response that we're going to get back is a payload that we're going to turn into string, of course. We're going to take out the string value there. And from there, I suppose we could just log each value, huh? We could also subscribe. We could do all sorts of things. So do on next log info, and we're going to just log the results. Log for J2. Alrighty. So each value that comes back, we're going to log it out. Okay. Or, you know, actually just here. Result log.info processing new result. Okay. Very cool. So there we go. There's our new results coming back from the server with different times. Okay. Good. So there's that. Let's now run this and see what happens. Oops. Was there somebody already there? Let's just try 2000 or 7001 because haha, that's actually correct. So 700 is I need to be running as root to do that, but 7000, well, that's easy. So let's just fix that. Okay, close this and that. There we go. So it's gonna, it's where the client, the consumer, is processing the message hello spring tips, and that message is being sent out every second, 50, 51, 52, 53, etc., etc., etc. So that's a very simple example of where we're making a request and we're getting a stream of data back. It could have been a publisher with just one value, certainly, right? This is a, you've seen this before, right? That would be easy, but it's kind of more interesting to look at how we can do a reactive stream back. All right, now this is fairly straightforward. Let's take a look at a slightly more involved example, right? Let's talk about duplex sort of channels, okay? And here we're going to play a game of ping pong. And this will just be back and forth as always. So public static main. Look at me go. All right, got that. Spring Boot application, and we're going to say spring application dot run ping pong dot class args. All right, so there's our application, and we have two things that are going to happen here. We're going to have the ping, and we have the pong, and this is a spring bean, as is that, and this will be an application listener, application ready event. Okay, open that. Okay, just copy and paste some code here to make things go a little quicker. All right, so the ping, even though it's ping, ping is the client, the pong is the server. That's the thing that responds after the first request has been made. So the pong, really, we want to make sure that gets started up first, right? So ordered. Okay. Ordered dot highest precedence and the ordered here return ordered dot lowest precedence. Very cool. Okay, so Pong has to start up first. We want that to be the case. And now we're going to send a request for the to the server, and we're going to get a response back, and we're just going to keep updating each other. We're going to do a simple state machine that's going to look at the incoming request, and then based on that request, send back either a ping or a pong. Okay, so let's extract that logic out into a single place here. Static string reply string in, and I'm going to say if in dot equals ignore case ping, then we return pong. If in dot equals ignore case pong, return ping. Simple, right? Otherwise, throw a new illegal argument exception. Incoming value must be either ping or pong. Okay, good. So there's my simple ping pong reply method. Now let's implement ping first, because that's arguably more fun, I guess, easier. I mean, it's all pretty good, but this one's a good place to start, since it's the first one on the code page. Let's first of all create a logger, so we have something with which to log, and I'll announce that we are starting the application up. So log.starting this.class.getName, and what we're going to do is we're going to say RSocket factory.connect.transport. I'm going to use the TCP client.transport.create. We're going to listen to port 7000. And by the way, there's a host you can specify there as well. You can bind to a certain IP address, etc. But I'm just going to go to 0000 and 7000. Start flat map many get a socket. Okay, so this is all fairly familiar. You've done this before. Then dot block. Let's make sure we get that right. Now, given the socket, we're going to send a request for a channel, full bidirectional stream of data. So here in the channel, I'm going to send a request at an interval. Okay, so we're going to say flux dot interval duration dot of seconds 1 dot map. Okay, and turn this into a default payload dot create ping. Okay, and now we're going to map that into you know, when we make that request. Let's see here. Is that right? We're going to request a channel. Yeah, that looks right. Okay, so we're going to request a channel, and we're going to map each response that comes back into a string, like so. I'm going to map each one of those. I just want to announce each one of those. Log.info received string in get class dot get name. We're gonna just take 10 of these, okay? So we don't want to run forever. And then finally, you know, one thing you should do, and I didn't do it in the last one. Do finally is dispose. Okay. All right. So what's happening there? Let's look at that code here. Don't look at that. All right. Did that work? So we've got now a publisher that's producing a new value every 10 seconds. And it's producing a new value every 10 seconds. MC. What am I doing wrong here? Interval. Good. Gonna map that. Okay, good. Oh, tag. I was trying to take, not tag. What's... Okay, there we go. I'm sitting there staring at the obvious error. Alright, so we've got this. Now, let's see. That's the basic code for the ping, basically. In the Pong side, we have a little bit more intelligence here. We have to have a little bit more intelligence, naturally. So let's do that here. In the Pong side, we're going to listen for RSocket factory.receive.acceptor, and we're going to use ourself as a socket acceptor. Well, first. Alrighty, good. And this transport TCP server transport.create 7000.start.subscribe. All right, so there's the there's that, and then the work of actually sending the socket back. That's what we do here, and we say mono. We want to create a new abstract RSocket, right? Just like before. So, and we're going to request a channel. Okay. So mono.just rs. Okay. And in this response, we're going to say flux.from payloads .map payload get data UTF-8 .do on next. Let's log this out. We have a string here. Okay, string. Oh, I guess we could just get a class. We need the logger annotation there. Alrighty. And and map the value that we got using ping pong. I'm going to turn that into a payload. Okay. And we'll send that whole thing back. So there we go. That's the whole. That's it. That's. I mean, I love that. That's very simple. So we're saying, when somebody requests a channel with values in it, we're going to take the publisher and turn it into a flux. Then we're going to take each value in that publisher of incoming payloads, turn it into a string, and log out what we received. And then we're going to create a response for that. So if the string that we received is ping, then we're going to send back a pong, or vice versa. And then we're going to send the response back. Okay. And in reality, I could have done the same kind of. I could have called reply here, right? That would be fine as well. I could have done that. I could have looked at the I could have done a whole number of things here to process that, but we already know it's going to be that. So let's. And much more interesting is seeing where it's happening, what's happening and when. Okay, so I'm going to do that. This is the ping pong application, so I'll start that one instead. There we are. So it'll continue for 10 cycles, one hopes. Okay. So isn't that cool? So in received pong, obviously, so the first thing that got sent is received ping in pong, right? And then we sent back pong, which was acknowledged here in ping, and then we received ping, etc. Right? So you can see the back and forth, the ball moving back and forth across the two different producers and consumers. So hopefully you've got some appreciation for what's possible here. Now this is a as yet nascent protocol. There's all sorts of interesting possibilities. This is the beginning, of course, as with all things. We'll start in Spring Framework 5.2. We'll see support there. The RSocket website, RSocket GitHub here. RSocket itself has some interesting stuff coming, right? There's a Kotlin binding apparently coming. There's a .NET implementation coming. That's pretty cool. Different transports, one of which supports Aeron, which is a super fast protocol that was developed by Martin Thompson, among others. And if you want something that is absolutely sympathetic to the machine, this protocol doesn't get much better than this one. So this is a transport that you can use if you want. You just add the libraries and use that. There's let me see, there's a Python and Go bindings that are, I'm not sure if there's any progress been made on theirs, but that's interesting. There was, as far as I can remember, a load balancer. Repositories. RSocket, let's see, RSocket Java. Oh yeah, there's a load balancing examples. There's a load balancer that's in the works. That's very popular. That bodes very well. There's micrometer integration, so you can actually capture metrics. And we've talked about micrometer in a previous installment of Spring Tips. So I encourage you to find that video and watch that to learn more about micrometer. All sorts of good stuff, coming, and more examples. In fact, I based some of what we talked about today on ideas that I gleaned from these examples. So if you want more examples, you should definitely consult this code. But also watch this space. So RSocket Netty, right? That's interesting. Watch the space though, because we're gonna have, like I say, in Spring Framework 5.2, we should have an integration for RSocket in the framework itself, with a component model that's a bit more high level, a bit more sort of naturally mapped to your business logic and to your business domain than, for example, RSocket factory.connect, whatever. By the by, you would normally, I only had one client. My consumer in this case was ping, and it only made one request ever. But you wouldn't normally do that. Normally, you'd start in your constructor, you'd start the RSocket client, and then whenever you need to make a request, whenever a client makes a request, you get a pointer to the RSocket client and make a request, right? So this is your gateway, if you will, to the RSocket service. So you would source this you'd stash this, initialize it in the constructor, and then use it over and over. All right. With that, my friends, I hope you got something out of this. I hope you'll check out the website. I hope you'll follow along as we introduce this in the year 2019. We'll have a better and bigger support for RSocket in the framework proper. And I hope you'll consider the possibilities. You can do reactive SQL data access. You've got reactive WebSockets. You've got reactive web flux for HTTP. And now you've got RSocket. What a time to be alive, all based on the underpinnings of Reactor, right? The Reactor framework. And by the way, I want to stress, this is not the only way to do Reactor-based RPC right now, right? But it is my favorite. It is, I think, the one with the most potential. Alternatively, there are some people that might be interested in the gRPC compiler from Facebook, right? Facebook has from Salesforce. Salesforce have a gRPC compiler, a Protalk compiler plugin that then generates Reactor-based services, which, that's kind of interesting. But of course, that limits you to the limitations of gRPC, which is to say it runs on top of HTTP2, and it assumes that you want to use Google protocol buffs, and so it can be kind of limiting. Plus, it's not. I don't think it's nearly so flexible as this. Remember, the folks that developed RSocket knew about gRPC, right? At Facebook, they certainly understood what was possible with that, and they still chose to go their own way, because that was a better solution. So, my friends, as I say, thank you so much for watching. Hope you got something out of this, and we'll see you next time.